So welcome everyone. It's a pleasure to have you here again. We are in our meeting on May 11th for the wheelchair testing centers. And as usual, I would like to kindly ask you to please rename yourselves using your name, the country, and the name of your testing center. This is just for ease of us for communication also. So if you can help me with that in this coming minutes, that would be great. And as most of you know, this step is very easy. You can just go ahead to the participants, and when you see your name, tap on more and then click rename. Now for today, we have three main areas. The first one is going to be quick updates from my side. So on my end, I'm just going to be describing a little bit of what you probably received emails from the testing centers group, and that's going to be like the main focus. Then we're also going to have the card drop with Dean Mubaiwa from ShonaquipSE in South Africa. And finally, we're also going to have our presenters, Jim Watson and Bob Appleyard from CIC, who are going to be showing us the test lab and the crash test. Okay. I also want to invite, I don't know if Daniel Chengo, he's a new member. He recently mentioned his interest in being here. So if you are here, Daniel, I actually do not see you. But if he joins, I would like to also introduce him to the group. We also have Steve Williams, who is a pleasure to have here today. Steve, would you like to introduce to the group, please?
Hello, hi. I'm Steve Williams. We don't have a testing centre yet, but we hope to. I'm from Uganda, and we are building bamboo wheelchairs and equipment. And we're in the development phase, but we've got a number of prototypes that are in the design process. So we hope to learn a lot from today for how we're going to go about doing the testing. Thank you.
It's great having you, Steve, and it's great seeing you again.
Nice to see you.
Thank you. We also have Holly. She's a PhD student at the University of Pittsburgh, and she's working a lot in rolling resistance. Holly, would you like to introduce yourself to the group?
Yeah, I can quickly. So my name's Holly. I think Stephanie actually did a pretty good introduction. I work on rolling resistance in the lab. We have a large drum-based test equipment that I've been working on testing and validating that method versus other methods. And I think that's about it.
Yeah, some of you may have seen Holly in the other group, the ISWP Standards Working Group. She has presented a lot of her research and her results in that group. So if you want to learn more about her, please feel free to join us on that group as well. And with that being said, I just want to let you know all of the members who are currently in this meeting have been added as a member for the testing centers at wheelchairnetwork.net. And this is going to be a Google group. So here we can post questions, all our conversations are going to be stored in that place. And we can also send the notifications and reminders. So similar to what you probably received recently for this meeting, it's going to be an entire email for all of us. So when you reply, all of the members are going to be able to receive your email, and you can also respond to everyone. So if there's a specific question about a test or a test process, feel free to post it there. We can use this group also as an interim between meetings, and maybe that can also help us populate future topics for presentations. If you have any comments or suggestions, feel free to do that as well. And I also want to show you really quick. I know some of you might already be familiar with this, but I want to make sure that I share this with you. So let me move this here so I can show you. The first thing you would need to do is just go to Google Groups. And you may need to log into Google using your email, the one that you have been receiving emails for this occasion. So once you see here, you're going to see ISWP testing centers. And on the left side, you're going to have people as the members, if you can see this, and also all our conversations. So everything is going to be stored here. And I'm going to be managing for identifying labels. So if there's a specific topic, for instance, you have any questions about the double drum, or if you have any questions about any specific topic, I can be in charge of labeling this, and we can start to populate all these questions as well. I just wanted to ask the group if you guys have any questions about this part or if you have any suggestions. Nope. Okay. So with that, I know it was very quick, so I want to introduce Dean Mubaiwa. Most of you have already know him, but Dean, would you like to start a little bit with your test? I have your video ready for you.
Yeah, thank you so much, Stephanie. Hi, everyone. This is Dean. I'm from ShonaquipSE in Cape Town, South Africa. Shona is supposed to be joining us quite soon. Today, I'll be presenting on the setup procedures on the drop test. So it is fatigue strength testing. It's just behind me. This is the equipment we have. It's one of the ShonaquipSE devices that we have called a SAM 18-inch. And then to it is a 100 kgs test dummy. Yeah. And I have a video that I had prepared. So Stephanie, if you could do the honors.
Sounds good. So I'll be sharing my screen again. Let me know if you can see everything and if the sound is correct, okay? Okay. Is that good? Okay.
Hi there. In this video, a demonstration will be done to show the setup of a wheelchair for fatigue strength test using the drop testing method. This method is taken from the ISO 176-8 standard 2014 version and was carried out at the ShonaquipSE Assisted Technology Testing Laboratory in Cape Town, South Africa.
Prior to testing, the following two environmental conditions need to be met for the floor surface hardness and the ambient room temperature. Step 1 is the wheelchair attachment.
The station is designed in such a way that 4 chain linkages are attached to the axle of the rear wheels and the other 2 linkages are attached to the frames connecting to the front casters. For this model of wheelchair, called the SAM 18-inch, the frame connecting to the front casters and the rear wheel axle are in the same horizontal plane. Therefore, all 4 chain linkages need to be of equal length. Since the standard requires that the wheelchair is dropped from a height of 50 mm plus or minus 5 mm off the ground, a wooden block of similar length is used as a step to allow for this dimensional adjustment. This is done for all 4 wheels of the wheelchair, and the chains are tensioned by adjusting the turnbuckles connected to the links.
The next step is to now place the test dummy onto the wheelchair. The test dummy selection and determination of center of gravity along with the setup procedures are taken from the standards ISO 176-11 and ISO 176-22 respectively. For this kind of test, it is wise to secure the test dummy by strapping both the torso and the thigh segments to the wheelchair. After attaching the test dummy to the chair, final checks are done, and these include setting the cycle counter to 0 and checking once again if the wheelchair leaves a ground clearance of 50 millimeters. After completing all the necessary checks, the test is now ready and the drop tester is switched on.
Forgive me, there's supposed to be sound in this video here, but
One last important check to make as the test is running is to make sure that after every cycle, the wheelchair is landing on all 4 wheels. These cycles are repeated for 6,666 times.
yes, thank you, Stephanie. So yeah, that's the presentation. As the same time as last time, I had to make a pre-recording of the video so that I don't take much time. But yeah, if there's anyone with questions, yeah.
Yeah, Dean.
Yeah.
It looks like you had the rear wheels locked on that test.
Yeah, so when I was loading, I locked them, but I did unlock them in the end. So,
Okay.
Yeah. But I did see one of the requirements in the status says that the wheels are supposed to have free motion, so they're supposed to be
Right.
moving.
Yeah, it helps to randomize the impact on the wheel.
Mm.
And Dean, I also noticed you were using the emergency stop button that you have on the double drum, also to turn it on and off. Can you
Yes.
use both machines at the same time?
So no. So what's supposed to happen is we're supposed to have 2 electric motors, one for the drum and then the other for the drop test. But something happened with the other motors, so I just borrowed the motor from the two drum and I put it on the drop test. So the switch is still connected to
Okay, got it.
Yeah.
Gee, that sounds like a familiar problem, Dean.
Yeah.
I've had to do that myself. Your videos are always really good. I enjoy watching your videos. You do a great job with those.
Thank you so much, Bill. I appreciate that.
They're great. They're very educational. I don't know if you guys have any feedback for Dean. I also noticed that Alvaro in the chat mentioned really nice work, Dean, for you.
Yeah.
Yeah,
Dean, can I just ask, is the whole frame, is it connected to the floor?
No. So if I can just show you. So the frame is not, it's actually, if you can see, so we have this rubber tiles that we have. Sorry for my goodness. So we have the rubber tiles and then we just have a wooden planks in the, yeah. We did this because the space we have is not that quite huge. So we are trying to have this spaces interchangeable because right now, as you can see, the 2 frames here, we are thinking of putting an impact test. So we actually made the pendulum bob and then the pendulum swing as well. So soon we'll be dismantling the whole frame and then we'll be putting in the impact test. Yeah.
Did you find that the frame moves over time? Does it move across the room?
So it doesn't move as such because of the rubber. I think the rubber mats actually give that grip, so that there isn't much friction between. There is a lot of friction, I mean, between the mats and the ground, so it doesn't move as much. We haven't done cycles to 6,666 as required by the standard, so it'll be interesting to see if it moves, when you get to something like 6,000 cycles.
Yeah, she might do. Yeah, and sorry, the last question is, you must have banged your head on that frame.
Oh yes. It's quite low, so a lot of times that's have my afro now, so that it just provides as a helmet.
You should have made it a little bit higher. Yeah.
You might damage the test rig, Dean, if you're not careful.
With my head, yes.
How thick is the mat on the floor? The black mat on the floor?
Oh, the mat on the floor, I think it's 5 millimeter.
Okay, so it's not real spongy.
It's not at all. And
okay.
And the room is quite cold, so it's not really, what can I say, spongy. Yeah, it's not, because when the temperature is quite high, that's when it gets, since it's a rubber material, but it's quite rigid. Because I know that it does specify that the surface should actually be hard enough that the maximum deflection when the chair impacts with the floor is 0.1 millimeters. So yeah, maybe we might move to concrete. Yeah.
That's a question, Dean. If there was a 6,660 cycles, and I guess that would take, how long do you reckon it would take? How many hours of running do you reckon it would take your rig to achieve that?
Yeah, so that's a good question, Bob. So as I mentioned earlier on, we still haven't done a complete test. Obviously, it would depend on how fast the motor is, but it also, the standard requires that, after every cycle, you allow for time for the wheelchair to be stationary. So after it impacts the floor and then it lifts it up, it makes sure that the chair is not moving. So it has to be, so that will actually affect our motor speed. So we can't go for fast speeds of the electric motor. But it'll be interesting to see how long it will take. I think it'll be, a week, because I know the test bed does take something like 2 weeks to complete, given we're starting at our.
Would you employ someone to sit over it, stand over it, and watch it, or would you have some kind of, I'm not trying to be smart ass here, but I guess some kind of automatic switch off device if there was a failure, some kind of failure detect mechanism. If you were going to run it, say 24 hours, or extended hours, rather than have someone monitoring it all the time.
Yeah, no, that's actually a really good question, because since we are also trying to expand markets, which means we want to test more devices at the same time, we did discuss this with Shona, where we need to look into automating things, because what we do now is when we come in at work, that's when we switch it on, and then when we leave, that's when we switch it off. So it does take a lot of time to complete cycles. It is wise to have an automated system where you can just run it 24 hours. It's something that we're having discussions over. Yeah. So always in equipment. Yeah.
If I could jump in here, when I run my drop test, I get about 6 drops in a minute. So it takes, to do the 66, it takes about 18 and a half hours for my machine to run. And I run it over the night. I have safeties on it, and I also have a web camera on it that I can check it. And I have a way to shut down remotely if I'm not here. So I still keep tabs on it when I'm at home. 2 or 3 times through the evening. And the only time it's not monitored is when I'm sleeping, which isn't very long every night. But I do have safeties on mine, so that if one of the chains would break, it would shut the machine down. But it takes about 18 and a half hours.
Just, I mean, the rig is really good and really simple and straightforward. I guess that an automatic shut-off device would be probably more complicated than the test rig, wouldn't it? Really,
almost.
It's good. It's good though, Dean. That's top work.
Yeah, there was because I was about to ask Bill as well, like how would you then place a safety system to make sure that it switches off? Because I know for the 2 drum we have a system where if the chair veers off too much to the right or the left, any sides, or somehow the test dummy collapses or falls off the chair, that's when the system triggers and then it switches off everything. But it'd be interesting to know how you would set up a safety switch on a drop test. I know you did mention on one of the chains. I don't know. Are there any other places you would think that we need to have a safety feature on the drop test besides the chain linkages?
I just have mine on the chains. So
Okay.
if one of the chains breaks loose, it'll trip a switch. I have.
suppose if you had some kind of simple pressure sensor, underneath the wheel, and one of them knocked out, wasn't making contact, that could intimate that there'd been a kind of a structural failure or something, which might need a shut. Something, maybe. Four bells with different frequencies, and if one frequency, something alternative, perhaps.
Yeah, because you might have a situation where the chair falls altogether and the chain linkages are still connected to the frames. So I'm thinking of a situation where maybe the wheel is bent, or maybe the frame itself of the wheelchair, the base frame actually bends, and you need to know. For the switch needs to know that it's actually something is wrong, and then it switches off.
Sorry, I have one question.
Yeah, go ahead.
Okay, hi, Dean.
Hello.
Nice work. I have two simple questions, but the first one is the mattress on the floor. The actual floor is concrete, is concrete, and the mattress is based on the standard. Or you cannot, or you can have this mattress?
Oh, so initially this space was free space. So we didn't have any mats. We just bought in new mats right now. But as the standard requires, it does suggest, it highly recommends that we use concrete floor, to allow for that deflection. So I still haven't mats themselves to see if they actually pass that floor hardness that is required. But that is a really important thing to actually observe.
Okay, no, just question. And the second one is about the frame. It's really nice, the construction, but when you design this frame, you consider the aspect of the frequency and deformations. That's why I am questioning this. Because it seems that after a while, you start to have some lateral and longitudinal dynamics on this structure. So you are losing some of your aspect on the vertical dynamic. So in some sense, you start to lose some of the actual forces normal to the wheelchair. And the suggestion of the bells, if you have a stiffness of the structure, that you design actually to not having smaller or small deformations, then you can presume that you have the 4 wheels on the floor each cycle. But have you considered some aspects of the forces around this frame when you design it, or it's based on the standard as well? I didn't get it. Thank you.
Yeah. So when we designed the frame, I think what I noted from the standard itself is most of there might be forces, especially when the chair lands, but since the chair is in free fall, we thought that as it's dropping, there aren't any forces that are acting on the frame or on the chair. So when we designed the structure, it was pretty much just to have an arm that just like lifts up and then drops. As it falls in free fall motion, we didn't think that there might be forces in the Y, especially in the Y X directions, as it's just like landing. So I don't know. It is something that is quite interesting to actually look into. Maybe we might actually need to, especially when it comes to moving, eventually over time, like the frame might actually just be sliding across. But that's something.
Eventually, some diagonal bars in the laterals, you can have a feeling of this opposite diagonally. On each side, you can have a feeling of this, but just a question. Congratulations for work, really nice.
Thanks so much, Carlos. If you want, I can just like run it one last time for everyone to see, but let me just
Thank you.
Yeah.
Yeah, that looks great. A little bit lower if you can, so we can see the entire thing.
Is good enough? No.
And I think we're seeing a little bit of the corner of the top ceiling. So okay, that's great. Thank you, Dean.
So it does get noisy. It's just like explosions.
I suppose that the failures that we're going to see are going to be in the wheelchair frame chassis, aren't they? Really, probably. Is that what happens generally?
Can you repeat your question? Sorry, didn't get that.
I suppose that kind of shock is going to really stress the chassis, the frame, the tubes, the welds, the butts, and all the rest of it. That's going to be where the failure is going to occur. Is that right? Anyone got an experience of this?
Yeah, so for my take is where the seat frame attaches to the base frame is where most of the stresses are going to go. Especially for the rear wheel. Because, you know, if you look at the Dash 11 standard for test dummies as well, the center of gravity is a little bit at the back. So which you have the back wheels and the axle will be taking a lot of force compared to the front side. Yeah.
Interesting to think how it works. How it compares with the rolling road test. You know, they kind of overlap, don't they, really? The drop test and the rolling road. I've never done either of them, but seen test rigs, but there seems to be a kind of overlap, you know. Good work, Dean. Top work.
Thank you so much.
Thank you, Dean. If anybody has any questions for Dean before we change to our new presenters. Yeah, well, thank you so much, Dean. And with that, I'm gonna give you the chance to prepare Jim and Bob. Just gonna remove the spotlight for you and add one for you, Jim, now.
Okay, yep, that's fine. Okay. Thank you, Stephanie. So I'm here in the lab. My name is Jim Watson from Cranfield Impact Centre, and this is our crash test facility for where we conduct 7176 Part 19 crash tests. So I'm going to what we're going to do is show you our facilities. This is at the business end of the track where the tests happen. I'm going to show you over there the wheelchair and our platform that we use for the testing, and then talk you through some of the details of our test lab. And then I'm also going to then show some videos and looking at some of the results as well of some of those crash tests. So if I just swing the camera around here, you can see then what we have here is that we have a 25-meter track where we can propel the sled, and then that goes into the a decelerating device which stops the sled, and then the wheelchairs carry on. So these are the this is generally the equipment then which we use then for our sled tests. So this platform then is what gets put onto the sled. So at this stage then I'd also introduce Bob Appleyard, who's also on the call. He's not here because he had to go somewhere, which he'll explain, and he'll be explaining some of the procedures that we do here. So this is the platform which we have here, which is what gets put onto the sled. Now, when we fire this the sled along, we stop this by a different device, which is which stops it by a wire brake system. So we start to bend steel wires, which gives us the pulse which we require. So this floor then is a rigid floor. Hopefully you can see there it's got tracks in, which we can strap down then individual parts, individual tie downs. So from a tie down perspective, it represents the floor of a vehicle. So we can take a typical tie down, we can put that into the floor, lock it in, and then connect that up to the tie down location point on the back. So these are all then adjusted or adjustable and locked into place as and when they're required. So we would normally run with one pair on the back and another pair on the front for Part 19 tests. So we have our wheelchair in place. So we have that set up along the center line. We have a occupant restraint system, which is here, which feeds from then this device around here, which is situated to represent effectively a B pillar of a car. So this has this is a wire rope here, which comes out to a belt. So it's a 3-point harness. This then gets fed through here, and then we have a lap belt, and this then is tied down then to the floor. So typically we make that up then for each test. So we have webbing material which we buy. It's this color because it's very good to be seen on videos. So we set this up beforehand, and we have and also we tie that then down to the floor as well. So what we use then to do that is we have a similar mechanism then to restrain the webbing as it comes down to the ground. So that's simply by passing through a very ornate system. We do that then to connect the occupant restraint system down to the ground. So so we have the tie downs, we have the occupant restraint system, and also we have with our wheelchair when it's positioned, we have a adjustment for the anchorage point as well. So this can move up and down quite easily and move from side to side, and we can adjust. Obviously, the wheelchair can move as well from side to side before we do the test. A couple of aspects of the test as well. Sometimes when we're routing the occupant restraint system through the wheelchair, it's very important that it doesn't catch on metallic objects around here, and which could easily break and tear the webbing. So you can imagine when the occupant is dummy is being propelled further forward, it doesn't take much. It could be a small nick in the webbing, and it'll tear. So what we use then is sometimes we use some protective sheath then for the occupant restraint system. So this is something sometimes which we use, which we just push into the webbing, and that sometimes gets positioned in place here just to protect that. The tests which we conduct, the majority of the tests we use is the 50th percentile. So this is a hybrid 3 test dummy. We put into to measure the trajectories of the head and the knee. We use these target markers. Now these target markers are very good at actually at measuring the displacement in all 3 directions, and also they can measure the rotation as well. But obviously for the test standard, we're only interested in the X component of that translation. So for the test, we have one high-speed camera which records these trajectories of the head, the knee, the chair, and also down here, which I hope you can see, is the target marker for effectively the sled, as that stays rigid. So when we perform the test, we can use the tie down system as for manufacturer's choice, or we use a docking station instead. So that makes it, when we do that, we have we sometimes use a platform like this, which is connected onto the chair, which is like a wedge. Now this is going to be a bit heavier to see, and this docking station is what we use then, and this gets bolted down to the ground. And effectively, what happens is from this on the chair, if you can imagine it. Now this is Bob, where you could have been here, holding this for me. This effectively comes in and locks in place. So the wheelchair doesn't need any of the tie downs. It will just rely on this to hold it in place. The effect of that is we do get different kinematics then for the test. So there's a lot of preparation needed then to do the test. We would normally be looking at the most we could do probably would be five or six. I think 6 we've done in a day. It's a lot of preparation work. So let me show you a couple of videos now, and then you'll see more details.
You're good to share your screen if you need to, Jim.
Yeah, I'll just share my screen then. Yeah.
I could sing a tune, Jim.
Yeah. Let's.
Notice the ShonaquipSE wheelchairs, left and right. The Mubaiwa on the left with a 10-year-old ATD ballast dummy only, and the what's the one on the right there called Dean?
Yeah, can we just turn that round there?
Yeah, that's the active user wheelchair with a tilt function and a pushchair on the left. Products of South Africa from ShonaquipSE, which performed very well indeed, we must say. The dummies there, the ATDs, child dummies, are basically TNO child dummies. 10-year-old on the left there, 36 kilogram, and 22 kilogram on the right. Yeah.
Okay, can you see that?
Oh yes.
Yep.
Yep. So here is the so this is a high-speed camera, which we need to film at 1,000 frames per second to be able to capture all of the trajectories. You can see it's quite a it's a severe test, and in fact, actually, this test here, the target marker actually came off the knee, but it's quite a severe test with a lot of tension going into the occupant restraint system. In this particular test, you do get large deformations there of the wheelchair. This is where we this video here shows the tracking that we do. So this is the system that we've used we're only looking at the X and the X value in this plot. It's a good way then of visually checking it as well, so we can see then what's happening to those individual points. I mean, for the element which we're talking about for the knee, you can see what happens there is the hand actually knocks off the target marker, but it's already obtained its maximum distance beforehand. There are also these target markers work a lot better than the conventional target markers which you see on crash test dummies. So that's there are two videos, one of them which is a general shot, and then another one which is a more of a general shot of the video. So I just want to show you now then if I just share the screen again, I want to show you some of the results then which we get then from tests. So this is an example of a pulse, a deceleration time graph which we generate. So the black line then here of acceleration versus time matches the criteria. So the things that we have to check on in terms from a test lab point of view is that we have to achieve a certain amount of time over 20G, which we do, and also a time over 15G. We also have to have the pulse has to be a certain duration in time. So that is measured by this time in here. So it's the time of the pulse, which is positive direction. And then becomes the four elements here are the four criteria which are needed for the ATD or the test, the crash test dummy. And then the fifth criteria is that what needs to pass is the knee to P point ratio. Also, from our side, from our point of view, we're running this as a deceleration test. So the test velocity, we measure the test velocity as it goes into the crash as it bends the wires, but we also have to record then the rebound velocity as well, and the velocity change, which has to be between 48 and 50 kilometers an hour. Up here, then you can see then matches that criteria. Other things which we have to record, officially the test mass, how we got to it, the accelerometer, the test engineer, and all manner of things, and we need to do those things for ISO 17025, which we are accredited for. So that means that everything, it has a traceability in terms of our weighing machines and our accelerometers all have to be approved by an ISO 17025 test house. So all the instrumentation that we use there is appropriate. So if any of these numbers don't add up, what we do is we operate on they go red in color, so it's quite easy to show then whether the item has passed or failed. We also have to produce a report for this for each test that we do, and that comes in the form of a Word document which will detail further information about the test. So the other thing is which Bob just mentioned there was the other tests that we've that we've got then crash test dummies, which we use instead. So I don't know if you can see can you see the video? Can you see the test dummies here again?
We see the test dummies here, yeah.
Yeah. So we have, as I said, the 50th percentile is the one that we use for the majority of times. We've also done tests for 95th percentiles, and that was the what we were talking about, Bill, was for that chair. You then have to use extra extensions on here. So we have a platform on each side to extend the width of the trolley to account for that wider chair. But what we also have here then is a 6-year-old dummy, and on this side we have the 9-year-old dummy.
10-year-old.
10-year-old. Sorry, not that's the other one.
36 kilograms.
Yeah. So this dummy here then has been developed from an existing crash test dummy, and we've made parts for it, or Bob has carefully made these wonderful parts, wooden parts, to represent the crash test dummy. So we're not measuring anything. I'll bring it into the center. So we're not measuring any instrumentation within the dummy in terms of accelerometers or load or anything like that. The crash test dummy has to represent effectively a ballasted mass of what the 6-year-old is. So we still have the orientation at the joints and at the knees, and these limbs here are all massed up to represent what a crash test dummy is. This makes for a far more cost-effective way of using an effective ATD, because prices of dummies are very expensive, and also having these wooden structures also means that they're a bit more robust, because they do have to be during tests. They can be quite violent tests. So in a similar way, some of these, as you can see on this dummy here, then we still have some of the parts are from the original as they were made by first FTSS, First Technology. Some of them are original parts, and we've used then additional parts to be added on. So these have been massed and with their center of gravity as well in the appropriate place. So these can represent the appropriate dummy. We've also got other sizes, smaller sizes, but these two are the ones that we're using for the crash testing. Now, also what we also have over here is for other tests which we do, where we have surrogate wheelchairs. I don't know if Bob, if you want to, do you want to talk through some of these tests whilst I lift this round?
Okay. Yeah. This is a surrogate wheelchair which is used for testing and developing and proving the integrity of wheelchair tie downs and occupant restraint systems. It uses a similar kind of test platform, surrogate vehicle floor with idealized occupant restraint system geometry. This wheelchair, which is of a standard design, which is given in the ISO standard 10542-1, has a common design, it's a common specification, which is used so that surrogate wheelchairs in being used to evaluate products in test houses across the globe will pretty much deliver the same results. The tie down points are in the same location. The center of gravity of the unoccupied wheelchair is constant. Yeah, there's the tie down points there, which have also act as some kind of gauge, so that to make sure that the tie downs can fit on a wheelchair. They're a kind of an intentionally large diameter. Two at the front, two at the back, as a standard 4-point tie down system. So that's the 10542 surrogate used for testing wheelchair tie downs, occupant restraint systems. This particular wheelchair, surrogate wheelchair, complies with the design requirements of Annex E of part of 10542, but also it has the capability of its mass to be augmented up to as much as 200 kilogram. And just behind Jim there, those yellow blocks which are on the test rig, these are or a number of those can be fitted into a kind of a square box underneath the wheelchair. They're about, I think they're about 15 kilograms each, those, aren't they, Jim? They look heavy.
Yes, they are. Yeah,
like you're working hard there.
Yeah. You just sit down, Bob. You just sit down.
Well, you know, I've retired, Jim. You know, I'm over 65. You young whippersnappers can just whip those. And there's a hole through, so you would stack those up upright, and there's a long bolt that goes right the way through from one side to the other through that hole that you can see just above that in front of the left wheel there, and ties them all in. And we can ballast it up in increments up to 200 kilograms. With so many wheelchairs, power chairs these days, of course, you know, topping 200 kilogram. The desire to prove wheelchair securement hardware that can effectively secure a wheelchair in this 20G crash event is an obvious extension to the requirements of 10542. So that's the tie down surrogate, Jim. Have you got the 16840 nearby?
No, we haven't. No, that's not to hand. No.
There is another surrogate wheelchair which is used for testing seating systems, which can be tested on a surrogate wheelchair. A seating system might be a specially shaped seat designed according to the individual requirements of a person with disability, somebody with a fixed posture, which needs a specially shaped seat in order to accommodate their physical features, with a view, of course, to either correcting, in the case of children, correcting faults or birth defects or some kind of growth defect, such as scoliosis or a windswept pelvis. Try to ameliorate those deficiencies, those problems, and that's very much the domain of rehab engineers, who we take our hat off to as mechanical engineers. So special seating systems, which are designed and built to accommodate the needs of particular individual users, can be, or a generic approach to that solution, can be tested on a surrogate wheelchair, and then the idea being that seating system, if it satisfies the test and its means of attachment to a wheelchair, a host wheelchair, could be attached to a Part 19 compliant wheelchair. So that's the other surrogate, which has features in it which are, accommodate attachment of those seating systems. They might be molded, they might be carved foam, they might be planar systems, modular systems with, you know, rigid uprights and seat bases. They're all kinds of different shapes for different purposes. And so there are three particular test regimes which we conduct with this particular test rig, which is the Part 19, 7176 Part 19 wheelchairs for use in transport, ISO 10542 wheelchair tie downs and occupant restraint systems, and the seating system test, which is Part 4 of the ISO 16840 series. So we offer quite a range of, the full range of dynamic tests for transport purposes with this rig. It has little extensions on the side that we can add for bariatric wheelchair users. We had a 26-inch wheelchair on there, which crikey, could almost have got 250th sat inside it, side by side.
I've got a couple of other videos here, Bob, to just show then. I can just go through some of these other videos, some like the alternative types of tests that we do. If I just share the screen, then this is perhaps this captures it. Perhaps this is in real time then of what the video looks like, what the test looks like, or perhaps a little bit lighter. And this is a different type of
oh yeah, that was that rear facing one we did, isn't it?
Yeah. So how we can construct then vehicle interiors, then looking at seats then and seeing how people when they're lying more prone, whether they what happens then. So in this instance we had a different test dummy, and it was looking for all those aspects of transporting people around in different positions.
Yeah, hold it there, Jim. If you can sort of rest it in the camera view. This is interesting. This is of course, those Part 19 tests are all about forward-facing occupancy in road vehicles. So forward-facing, upright-seated passengers. Wonderful. What about those people who can't sit upright? What about those people who are in this kind of semi-supine position? People who are practically living their lives laid out flat or very nearly flat. And this particular seating system that we tested here, which is a molded insert, you can just see the shiny part of the back base, fitted onto a tilt-in space wheelchair, which this young lady who was 26, 27 years old, I think now, was her actual wheelchair, which was replaced as she outgrew this particular one, and we simulated to prove that we were doing the right thing by suggesting a rearward facing orientation in a 10G. Now, this was a 10G crash rather than a 20G crash. That it was far more survivable as a risk control measure to change the orientation of the passenger and also to choose the type of vehicle that she would be traveling in, and to one which has a naturally less aggressive crash characteristic. So this wheelchair was pushed up against some bus seats, minibus type seats, which Jim managed to what's the word?
Acquire.
That's the way. Yeah.
Yes.
From a nearby bus.
Fall into our possession.
Yes, somehow. You could have told me when I was cutting the bolts off. But anyway, it was so we arranged it on the sled, and it forms a kind of reaction for the push handles of the wheelchair, and the ATD, which is, well, actually it was a ballast. It's a manual handling ballast dummy, because there isn't an ATD which could effectively represent the actual user that we were looking for. So we created this, and using a manual handling emergency evacuation dummy, and ran the test, and the results were amazingly boring, really, Jim, weren't they? Because nothing happened.
They were, yes, yeah. And, we like that.
It was so boring. Jim said, well, let's do another one at 20G, which we did. And then we did another one at 10G frontal, didn't we, Jim? And that was,
yes, we did, to
prove just how bad it would have been in a frontal impact with that kind of posture. And this any occupant with a 3-point harness, which is intended to be used for someone with an upright seated posture that is compliant with 10542, would have basically it would have euthanized the occupant. The lap belt would disappear up into the chest, and the shoulder belt engaged with the neck and pulled the head right back. So it was shocking. And we're hoping to gradually kind of break into the subject of safety or risk management or risk reduction, risk control measures for people with more severe forms of disability, which I think is really important work. I mean, we're doing this here in the UK. What's it? Oh, this is a real actual vehicle test. That's a GoPro camera, isn't it, Jim?
Yes, on board, yeah.
On the back rear header of a kind of what do you call it? Like a utility van, which has been converted for a wheelchair accessible vehicle, 20G environment. And you can, if you look at the base, you can see the wheelchair is sat inside a kind of a tub where the floor has been cut away to increase the kind of height, the floor height, the height between the floor and the the roof of the vehicle to make it more. Those wheelchair users sit pretty high at around about 1350, 1450. It runs a 10542 test in an actual body shell.
Yeah. So there was just a couple of other ones. Yeah, Bob, I just wanted to show then. Yeah. Of other videos of crash tests that we've done. So I don't know if we open it up to the
questions
up to the floor then. Yeah, if anybody wants any questions or if there's any any further information about the test, Bob will.
Yeah, Jim, I have a question.
Bob will answer them all. Yeah. Sorry.
I have a question. So I'm not an expert on the WC19, but is it that you only test this on an upright position, or as you mentioned, like on the previous one, it was a little bit tilted and rearward facing? Do you also test, for instance, power wheelchairs with a tilt and recline on the tilt-in position?
Yeah, indeed. Yeah. That's a fairly frequently asked question, Stephanie. The Part 19 standard is kind of the scope of the Part 19 standard is, I wouldn't say it was narrow, but it's confined to forward-facing, upright-seated passengers, and the kind of definition for upright-seated starts to become kind of woolly when you start to have seat back angles greater than 30 degrees. When you have tilt-in space facilities, tilt wheelchairs that kind of go beyond 30 degrees, you're starting to move away from upright seated and you're starting to go into this semi-supine condition, this semi-supine posture. I did look up the meaning of the word semi-supine and it doesn't exist. It's a bit of tautology, really. It's either is supine or it isn't. It's a digital thing. But I think that for our purposes, we kind of this extreme angles of tilt, we lose the quality of occupant restraint system deteriorates the further we rotate the seat system backwards. And so there is a kind of a limit which we've set amongst ourselves. And I guess that's kind of RESNA and ISO and PMG, the posture and mobility groups, and of 30 degrees, a kind of a tilt angle, backrest angle, back support angle, 30 degrees is a limit. And it really, it's to do with the effect of the occupant restraint system, not the hardware. It's it's how well we can restrain an occupant. It just gets too dangerous. There, has that answered that one?
Yes, thank you. And the other question I had is, at what speeds do you test this? Like, is it only at a single speed, or do you test, I don't know, like 20 kilometers per hour, 40 or 60?
Ah, right. Yeah. Okay. Good question. The crash severity, which is employed to determine the suitability of a wheelchair to be used in a motor vehicle, is kind of based on the accepted crash characteristic for a worst case passenger vehicle. Worst case, well, it's a passenger vehicle such as a day van or a car. They have this, they're said to have this 20G, 30 mile an hour crash signature. If you put a number of vehicles of that type into a wall, into a barrier, you would kind of, on average, you would determine a kind of a broad basis of a 20G deceleration. And that 20G is, maybe it's got its roots in some history, some early history, but it's used as across the automotive industry as a benchmark expression of crash severity for a smaller passenger vehicle, up to around, well, in the UK, in the EU, they say vehicles that can carry 8 seated passengers. Any more, than 8 seated passengers, and the type of vehicle changes and the type of construction changes significantly, so that the way that larger vehicle might be operated as well change significantly, that you can reduce the crash characteristic to 10G from 20G. But so we base the standard for all three of the wheelchair related ISO standards, and I think that it's kind of shadowed in WC4 in the anti-resonance standards for the same volume 4, isn't it? I think they call it, and it's all 20G, 30 mile an hour or 48 kmh. So yeah, we could. That rearward facing test there, we were proving in a 10G environment, which in Europe, 10G for ambulances is the accepted crash characteristic for, patient transfer emergency ambulances. It's similar in the States and Australia, but I think that's slightly more aggressive, I think. So no, the standard tells us what to do in order to comply with the standard. So is that okay?
Yes, thank you.
Hi, I have one question, please? Nice presentation, thank you very much. And first question is, are you a center, a private center, a governmental center? Sorry, asking because I'm not familiar, just for curiosity.
We're right. Yeah, we're our company name is Cranfield Impact Centre.
Oh, okay.
And we are and we're based at the at Cranfield University, which is a Cranfield, yeah.
Okay.
Which is a postgraduate university.
I know Cranfield. Yes, I have been there.
80 kilometres north of London, and we but the company which we are a spin-off company from the university. So really although we're owned by the university, we are a commercial company. So
really nice.
We're not an academic department.
Okay.
We're a company then which exists because we do, not only do we do wheelchair tests, we do Formula One crash testing, we do ambulance testing, all manner of different materials and crash testing that we do.
Okay, thank you. And the other question is, no, just one more. The neck of this dam, you have really nice dams there, but the neck of the one in the wheelchair, it's a mechanical spring, or you have some kind of a polymer rubber?
Yeah, there's what it's made of is there's rubber sections here. The black parts are rubber, and
it's solid?
and the metal reflective part. No, it's not solid. In the middle of it, there's a steel rope that connects the top to the bottom of the cervical spine. So this dummy is also only designed to work as a frontal dummy. It's a frontal crash dummy. So I can do that, and by doing that, what I'm doing then is stretching the steel rope as well as compressing this side and extending on the back edge, and vice versa. So I don't know if you can see, but on this side, there's a slit, there's a cut.
Yes.
In the rubber, which allows for that motion. So we get the forward flexion and then the extension we get then for when it returns.
And you have a similar value of stiffness of our actual neck of a human being.
Well, it's inherently, because it's a crash test dummy, the stiffness of this is a lot stiffer than what a human neck is. So I can't do this really with a with a human neck. But it's but in a crash test we frequently get the head comes right down to here. I can't do it myself.
I saw in the video the movement of the head. Yes.
That shows that then. Yeah.
Oh, great. Thank you, Jim. Okay. Thank you very much.
Thank you.
Yeah, those dummies are developed in the States, Wayne State University, I think. And we have to thank Ralph Nadar for that. He kind of instigated or I think there's compensation for something that he exposed. I think that Wayne State University were funded by GM to develop the Hybrid 3 dummy. And there's quite a lot of information on the development of the Hybrid 3 based on cadaver testing. And some of the books and paperwork on cadaver testing are quite, but it's serious business, you know, and people clearly donated their bodies to medical science, and there's an awful lot of respect for those people, and the Hybrid 3 is a well-respected, within the industry, is a well-respected piece of apparatus because of what it does. It might not be, it is truly a 50th percentile. It doesn't represent anything more than 50% of the male population. But there's an awful amount of respect for the work that went into them.
Really nice, really nice.
Which Nicole will talk to us about.
Yeah, she's actually interested in presenting in our next meeting. So, Nicole, if you see something that you would like to talk in a little more depth later, feel free to do that, or maybe gives us a heads up of what we're going to be seeing next.
Yeah, it's going to be pretty similar, I think. But I can find some other things to talk about that we do here. So.
We look forward to that one, Nicole. That'd be great. Because I know you guys have got no end of experience with perhaps, you know, a bigger range of dummies than Jim has available. We have to hire in a fifth and a 95th, and which we'd like. If ever you hear of either of a 50th or a 95th going second hand, Nicole, let us know. And Jim will pay cash and food. And wine and things.
They're hard to get their hands on.
Yeah.
Thank you so much, Bob and Jim, for your presentation. It was also very interesting, and I want to thank you all for being here today. I want to open up for a discussion if you guys have anything in particular you would like to talk about today, or if you would like to propose any new topics. I know we have some new members such as Steve and Soycat, so if you're interested in seeing any particular tests, this is your chance to propose as well. We can talk among the group who would be interested in presenting next and what are the main areas you're interested in. Okay. Let me see. But if not, I think we have a couple more minutes left. I just wanted to mention that it was brought to my attention that a lot of people in the group are going to be out for vacation around July and August. So even though we generally meet every 3 months, our next meeting would be mid-August. So I was going to propose if you guys are all okay with meeting in September, so we are all back in business and we can have enough time to present and prepare and also enjoy summer for those who have summer in this time. So sounds good. Thank you for the thumbs up. And I also have a message here from Soycat. So thank you so much, Soycat, and feel free to jump in with ideas. You can send me an email, or also send an email to the testing centers, and I'll be happy to hear from you in the meantime. And I'll be stopping the recording now. Thank you.